Hi everyone, I'm going to be explaining problem number 9. So here goes. There are several equations that are necessary to solve this problem, so I've listed them all out here and I'll go through them. So the first thing to do is think about the conservation of energy. Here we have potential energy equals kinetic energy, QV equals 1/2 mv squared. Isolating v, we get this, which is important because they don't give us a velocity in the equation, so we need to have a substitute for it. So keep that in mind. And then next we come down here and we have F equals ma. We know QV cross B equals F, and in this case V and B are perpendicular, so it's just QVB. And instead of ma, we have mv squared over r because of the centripetal acceleration that the particle is experiencing. So isolating r, since r is what we're looking for, we get mv over qb. Like I said before, we don't have a velocity, so we need to substitute in for that. And then down here we get r equals m over qb times this value here, which simplifies further to this equation right here. And this is going to be important. So we have two different particles, so we're going to have two different radii. So if we look at R2, we have M2 and Q2 in this same equation that we found earlier. And we have R1, M1, and Q1. And the best thing to do for this is to set up a ratio. So if we put R2 over R1, everything else cancels except for the masses in the Q's, I guess. So we have the square root of M2 over M1 over Q2 over Q1. Using these ratios they give us in the problem right here, we substitute in and we get the square root of 1 over 6. Rearranging this equation even further, we get R2 equals R1 over the square root of 6. R1 is given, and we're interested in finding R2, so if we plug in for R1, we get 1.2 over the square root of 6, which gives us 0.5 meters, which is answer option C.